Welcome to the Micronaut podcast. I am your host, Sergio Del Amo, and today I have a very special episode. Szymon Stepniak, the creator of Files, a project which has been filling our Twitter timelines with great Micronaut tips, has interviewed in the recent GraalVM community meetup Micronaut founder Graeme Rocher, and he has been so kind to share the interview with me. So I will leave you later with the interview for you to enjoy. But before going to the interview, I have a couple of housekeeping to do. First, I would like to talk about the agenda. We released the Micronaut 3.7.0 today. Hurrah! It's full of features. I am going to include a link in the show notes, but just check it out. There is really probably something for everyone, depending on the modules that you are using. We will probably talk in another episode about some of the features with more detail. I wanted to also cover a couple of agenda topics that we have upcoming. We have an in-person workshop in London about Micronaut and AWS Lambda, which I will present myself. And we have also Graeme Rocher. Speaking of Graeme, he's going to be talking at Java 1 about Micronaut. I think he has a couple of sessions. I will include a link in the show notes to both. And last but not least, we have an upcoming Micronaut data training. I will include a link in the show notes as well. So if you are interested in learning about Micronaut data and everything that it has to offer, which is many things, please don't hesitate to attend that training. And with all of this, I'm going to leave you in the interview. Thank you.
Let me introduce our first guest. He's the creator of Grails framework and Micronaut framework, Java champion and Oracle Groundbreaker award winner, architect at Oracle Labs, and last but not least, a very humble and kind open source community member. Ladies and gentlemen, Graeme Rocher.
Thanks for the intro. I think you said everything that needs to be said, and very humble to be introduced in that manner. I think it's probably a bit much.
Graeme, can you tell us a little bit about the upcoming Micronaut 3.7 release before we move forward?
Sure, yes. So that's coming very soon. With the minor releases of Micronaut, we're trying to deliver frequent minor releases every 6 weeks that bring value and new features quickly so that people can try things every 6 weeks. And that's no different with this release. So there's a number of areas we focused on. So we've built a new module that defines an abstraction over cloud object storage implementations. So things like Amazon S3, Oracle Cloud Object Storage, Google Cloud Object Storage, etc. They each provide, a cloud-specific API, and that makes it difficult to create cloud-portable applications because when you want to move from one cloud to another, you have to code essentially to the cloud-specific object storage implementation. And if you're doing anything which is quite typical in the cloud, where you're storing file uploads in buckets or whatever, it introduces this coupling. So that's one of the main new features, where we have this abstraction where you can upload files and download files essentially through an abstraction, and then reconfigure your app for different clouds and redeploy, which aligns with our focus on trying to make Micronaut kind of multi-cloud and cloud portable abstraction and so forth. We also have improvements to our Spring support. So we have a lot of folks who are using Micronaut, but they have Spring applications already, and they're looking for ways to share code between a Spring app and a Micronaut app. And it's been an often requested feature. I have a Spring app. It defines some library that defines common beans that I can inject into my Spring app. How can I get this into my Micronaut app so that I can reuse that existing library or logic? So we've implemented support for Spring Bean import. Essentially, you can take an existing Spring library and add an import statement as an annotation to your Micronaut app, and it will generate a compilation time beans for those equivalent Spring beans. So you can create shared libraries that can be used in both Micronaut and Spring. With Spring, it does the analysis analysis at runtime, and like it always does, figuring it out, using reflection and so forth. With Micronaut, it does everything at compilation time and wires it into the existing compilation time mechanism, and you can dependency inject those components into your application, which I think will be very useful for a lot of companies out there who have, existing Spring apps and Micronaut apps living side by side, essentially, providing that migration path, so I think that's a big deal. We've also implemented support for cloud logging solutions, so specific integration with Logback, so that you can log directly to AWS Cloud Watch, and you can log directly to Oracle Cloud Logging, or we already had support for GCP logging, so now you can provide different configurations for different clouds to export your logs. Because, I think that's an important aspect, because, when most logging systems in the cloud, you essentially get system out line by line logs, which is not really what you want. You want to set the whole log in the JSON format the cloud wants, so that you can expand it and look at it and read it and understand it in it more. And of course, if you have a lot of microservices, you want to expose the trace IDs, and the span IDs, if you're using distributed tracing, so that you can see, trace a call from one call microservice to another and retain those. So it links in with our kind of distributed tracing integration, which we released, in Micronaut 3.6, we released support for OpenTelemetry, which was a big deal for a lot of users. And this expands that to help make sure the logs are consistent in the cloud, which is pretty cool. And I'm probably missing something because there's a lot of things that go.
This is already,
it's already quite a bit. And we can, keep the incremental nature of providing value in these minor releases of Micronaut.
Could you tell us a little bit what is coming in the upcoming future Micronaut 4 release?
In general, with major releases, we haven't changed a lot. If you look at like Micronaut 2 to Micronaut 3, it was more an opportunity not to introduce new features, but to remove deprecations and upgrade libraries, third-party dependencies from one major release to another. So Micronaut 4 is going to be the same in that we will remove deprecations, clearly. That things that we've deprecated that users have known for a long, for a long time have been deprecated. And the other thing it will be is upgrading the third-party dependencies to the newer major releases. So that's, we will probably complete the migration from, which we started already, from the JavaX .namespace to the Jakarta .namespace. I think there's a couple of things that are not, validation I think is not yet migrated. And just complete that so everything is Jakarta namespaced. And then I guess the biggest change for users is that we are baselining on Java 17. So that also has the implication that we will maintain Micronaut 3 for a long time, because Micronaut 3 is Java 8 baseline, and we have many users that are on Java 8 and going to stay on Java 8. So it's likely that we will even still backport features to Micronaut 3, and of course maintain patch releases, security updates for many years to come for Micronaut 3 and Java 8. But I think it makes sense at this point to make the move to Java 17, because it does allow us to innovate in lots of different ways that, I don't think moving from Java 8 to Java 11 does anything for us in terms of exposing productivity improvements to the API, or, whilst Java 17, we have things like records, which we can integrate into the API. We have things like sealed interfaces and sealed classes, which allow us to define the extensible parts of the Micronaut API in a clear manner. Right now we have certain classes, interfaces that are annotated with an annotation called @internal. And we can say, this is a sealed interface now that, that's not, part of the internal API of the framework rather than something end users can utilize. And and then there's a lot of obviously things at the JVM level that have been improved. We could probably take a lot of Micronaut's compile time metadata is stored in static fields. Not so much for GraalVM, which initializes that at build time, but for the JVM, we can probably do things like use const dynamic to basically initialize those constants that lazily as they're accessed, potentially saving memory, in other cases. So there's benefits to making that jump, and that users I think will appreciate. And the other thing is just like guides and documentation. Currently all of our guides, all of our documentation are Java 8 baseline. So when we write a guide, we don't use the modern features of Java, right? And Java has evolved significantly, it's in Java 17. So, our guides and documentation should recommend the use of records, should recommend records, should use switch state, switch expressions and all the kind of latest and greatest things that are in Java. They shouldn't be recommending essentially Java syntax, right? Java 8 syntax.
Especially that many Micronaut free users are just using Java 17 these days, right?
Yeah, exactly. So, and of course our users can go to the, other sources of information, but, I think a lot of people look at the Micronaut guides as a kind of guidance on how to use the framework and, we should best practices and.
Exactly. And someone sees, why they are not using, I don't know, like the records in the examples. They just keep using POJOs.
Yeah, or POJOs. Yeah, exactly.
There is no var keyword used anywhere. So people may see, you are still in this very old code base, which may also look like the framework is not aligned with the modern technology.
Exactly. So I think, because the way we write the documentation for Micronaut, I'm not sure how many people are aware of this, but every guide, every snippet in Micronaut is actual code. And we use ASCII doc to include real code snippets that are tested. So not a single snippet of documentation that goes into, snippet of code that goes into our documentation is untested code. It's all real code that runs as part of our test suite in all of the guides, all of the documentation. But of course, our build system and everything is Java 8 based. So we can't put into those snippets
the
new language features because that would fail our builds or anything as much, even if we wanted to. So it's kind of interlinked with the way we build and everything. The way and there's, I think we need the whole Java industry, I think, needs to embrace Java 17 and move forward. And I think it'll be a big deal for Micronaut 4 to, baseline on Java 17. And obviously it's a big change, for a lot of users. But, our intention with Micronaut 4 is not to break anything related to Micronaut, right? It's to baseline on Java 17, remove deprecations, upgrade dependencies, but we're not looking at changing Micronaut in many significant ways or breaking applications. Our hope is that it's an easy upgrade, but obviously, when you're baselining on a new version of Java, I guess that will be the biggest factor for people upgrading, I imagine. And it has different implications. Just now we're starting to work on upgrading the Gradle and Maven plugins to, use dependencies that are baselined on Java 17 and upgraded and so forth. And, there's things like, new major, things like Gradle 8 are coming out soon. Do we baseline on Gradle 8, for Micronaut 4 and, that kind of thing. So, there's lots of unknowns still. We're still trying to target the end of the year. That's definitely not a hard deadline, but the work has started already. And of course, the other thing, looking beyond Java is Groovy 4. In terms of the Groovy audience, we're still on Groovy 3, moving forward.
So the Micronaut 4 will also provide the support for Groovy 4, yes?
Yes.
I tried a few times using Micronaut 3. It was something like 3.2 at the time. And I trying to force the latest Groovy version, but it didn't work.
Ultimately we integrate with a kind of managed version of Groovy 3. And that's what we support because of the way we integrate Micronaut with the compiler of Groovy, and all of that has to be moved to Groovy 4.
What is your opinion on Groovy 4?
So I think it's important for Groovy to keep advancing and moving forward, and there's a lot of great features and advancements in Groovy 4. It's nice to see the language moving forward, right? And Groovy is still vitally important for so many parts of the Java ecosystem. For us, we in Micronaut, even though Micronaut is primarily a Java, most of the code base is written in Java, but 80-90% of our tests are in Spock. Because and I'm not sure how we would even write our tests without Spock, because the way our tests are written, we have a lot of tests that essentially dynamically compile Java code, and then using multi-line strings in Groovy and often string interpolation, dynamically compile a Java class and instantiate and basically build a kind of embedded application context, and you get a bean back. But then, you often need to invoke methods on that bean. And, if we had to write those tests in Java, we would have to use reflection, like reflective APIs to essentially...
Which is something you want to keep away from Micronaut anyway, right? So,
but for our tests, it's useful, right?
But then when people see, okay, but here you are using reflection here, so maybe we can also try to apply it.
Well, I think that the framework layer is different. One thing is your tests or whatever, and that's where Spock shines, and we can apply assertions and do dynamic compilation inside of our tests to tests, because Micronaut essentially is a compiler plugin for Java, Groovy, and Kotlin. So we have to, dynamically compile source code and then test the result. So for that use case, Groovy and Spock are ideal. But in terms of what we generate with Micronaut for consumers of the framework, from the beginning we designed it to not use anything dynamic at runtime. And when I'm referring to anything dynamic, a Micronaut app doesn't do dynamic class loading. It doesn't do reflection. It doesn't do runtime generation of proxies. It's fully static at runtime. That has a simplicity to it because it's at runtime, Micronaut is really simple, relative to, there's no class loader hierarchies. It's just a system class loader essentially. And that has facilitated Micronaut's ability to be compiled into native with GraalVM really easily. The challenge is primarily, third-party libraries. But if at the framework level, it just works, right, with GraalVM native image.
So you mentioned that the Micronaut application can be easily compiled to the native image. Can you tell a little bit more about that?
Yeah, sure. So it's actually interesting how that materialized, historically. Micronaut was open sourced in March 2018, and literally a month later, GraalVM. And, we kind of looked at the requirements for Java application to be converted to native. And it said, you have to configure, if you can compile to native as long as you configure, all the uses of reflection, all of the uses of runtime proxies, dynamic class loading, etc. and then you have a working application. And we were like, okay, well, we're not doing any of this. It should just work, right? And, after a few tweaks, we had to, do some things to get Netty working. It just worked, right? And because Micronaut is all static class loading at runtime, direct method dispatch, relatively simple to perform a closed world static analysis. And that, I think that, that has allowed Java, native image in particular, has allowed Java to go places where, it was just not possible to take it before, or opened up use cases where, which were not feasible before in Java. I think, a lot of people at the time were questioning, does Java have a future in like serverless workloads or even containerized workloads in Kubernetes? Or, because of the startup time, consequences. And, native image solves a lot of those concerns. And, we've seen big uptake, in Micronaut, plus GraalVM plus AWS Lambda, for example. And in general, serverless, Cloud Run, etc. So that's encouraging, and beyond that, opening up the possibility to, finally create native command line applications with Java, right? Which was, never really a thing, right?
Exactly.
Embedded devices, IoT devices, Micronaut running on a Raspberry Pi.
So is the fast startup time the only benefit of going native?
No, I mean, there's several benefits. There is a reduction in CPU usage, in general, both for startup and during execution. There's the reduction in memory consumption. So, a Micronaut app compiled into native, with GraalVM, apart from the startup, which is in the low milliseconds, uses a fraction of the memory of, the full JVM. And that reduction allows you to run more instances, or in the case of Kubernetes, more pods, more, in parallel. So, and scale out, like I said, the reduction in CPU usage overall, if you really see that in limited CPU environments, when you start up, Micronaut on like a Raspberry Pi, for example, the amount of processing required, to spin up the JVM and do all the initial JIT processing and so forth, it takes, probably around, the last time I looked was around between 20 and 30 seconds before a Micronaut application starts up on a Raspberry Pi, but with native image, it's a fraction of that. And then, it doesn't occupy as much, CPU time in general. So there's several benefits. Obviously there's downsides as well. There's the loss of write once run anywhere. You have to compile for a certain architecture. You have longer compile times. You may have, lower peak performance because the JIT isn't, there's no JIT to continuously optimize your application. But it's a trade-off, and it's a trade-off that's allowed, Java to be used and Micronaut to be used in numerous cases that wouldn't have been viable before.
And how about libraries that use reflection? As far as I remember, Jackson is one of those libraries where it uses reflection heavily to serialize and deserialize objects from the JSON format. How Micronaut solves this problem? Well,
first, there's two aspects. For Jackson specifically, what we did was we wrote a Jackson module that uses Micronaut's what they call bean introspections. These are compilation time produced types that allow you to read and write bean properties and construct objects without using reflection. So we wrote a Jackson serialization modifier and deserialization modifier that essentially allows Jackson to be used without reflection. And that is pretty popular because now with Micronaut, there's even if you're using Jackson, there's no reflection happening, right?
Yeah. And that's why we also have to remember about add introspected.
Exactly. The downside of that is, you have to add an annotation to the type, right? So you add introspected. If you don't add it, it falls back to reflection. falls back to using Jackson's normal reflection approach. But recently we've taken that further, where we've actually implemented Micronaut serialization, which is a alternative implementation that is 80-90% compatible with Jackson annotations, but doesn't use Jackson data bind at runtime. So Jackson data bind itself is like, I think it's like 2.4 megabyte jar file, and because it's a lot, it's fat, it's because it has to have a lot of infrastructure at runtime in order to, largely reflection based, in order to allow objects to be serialized and deserialized. And, it has caches for that data, because when you retrieve reflective data, it gets cached somewhere. And there's a lot of heavy weight infrastructure that any reflection based library will have, right? So with Micronaut serialization is like 300 kilobyte, right? And it's a small jar that implements 80 to 90% of the Jackson functionality that exists. So you can still use Jackson annotations. You can also use JSON-B annotations if you prefer. And you can pick which actual JSON parser you want to use at runtime. So you can use Jackson's parser, which can be used without the data bind component, or you can use JSON-P if you prefer standards based approaches. And because we've abstracted the encoding and decoding layer, and it's completely reflection free, right? And for native image, it actually reduces the size of the native image by 5 to 6 megabyte, because there's no Jackson anymore, no Jackson data bind, essentially. And we've also been hardening it because we also wrote a encoder and decoder that's based on BSOM, which is MongoDB's encoding and decoding format. And Micronaut data MongoDB is based on Micronaut serialization. So every time a user, and we're seeing a lot of adoption of Micronaut data MongoDB, every time a user uses Micronaut data MongoDB to serialize and deserialize objects from MongoDB, it's using Micronaut serialization under the covers, which again, zero reflection in play, lower memory footprint, smaller runtime. Micronaut is all about moving things to the compiler so that the runtime stays small. Yeah, and that's
predictable.
And predictable. And the Micronaut serialization is just an extra component of that. The runtime is small at 300 kilobyte as opposed to megabytes of infrastructure needed to support a reflection-based library. And that's like the same thing with the rest of Micronaut, right? If you look at, we do all the computation for things like generics and everything during compilation time. Whilst if you look at something like Spring, it has like a 2,500 line class to resolve generics from reflection-based data. And that just doesn't exist in Micronaut, right? Because the runtime is smaller. We do all that infrastructure to compute all of that is in the compiler, and we leave the actual runtime lighter weight.
I guess solving these kind of problems with solutions like Micronaut serialization or just the Micronaut data bind module makes you really proud of the work that you put in the Micronaut. But I would like to ask you if there is something that you would like to change, if you could just go back in time and start, Micronaut pre 1.0 release.
Yeah, I think I would, I think we were maybe a little bit too opinionated in certain areas. I don't think we anticipated all the different use cases that Micronaut would be used for. We started off obviously focusing on REST microservices and so forth. But, then adoption kicked off and we had people using Micronaut in a lot of different scenarios, which, from serverless to desktop apps, to command line apps.
And as you mentioned, embedded devices.
Devices, right. So there's probably, maybe a little bit too much in the core. I would say, like, for example, we have this feature where it does like cloud detection, where you run your app and it detects what cloud you're running on and automatically activates a particular profile. And that's like not needed in embedded devices or
command line.
So you have to explicitly remember to disable that, and that's not one of the things I want to fix in Micronaut 4 is like disable that by default. But we've been cautious about that because we do know we have a lot of users who use cloud as well, and it's a really useful feature because you can run your app on Google Cloud or on Oracle Cloud or on Amazon, and it'll automatically, hey, I'm running on AWS. Hey, I'm running on Oracle Cloud, and then you can reconfigure it dynamically. But the feature has a cost, in terms of startup, and I guess we have more work to do on the separation of the compiler to the runtime. So, like when you run things at runtime, sometimes there's actually a little bit too much in Micronaut in terms of things that exist. That should only exist in the compiler, but are still there in the runtime. So Micronaut 4 will be an opportunity to fix some of those things, as every major release is. But, I think those are the main ones. Is like, as Micronaut has matured, we made it more and more modular and thinner and smaller, but maybe there's even an opportunity to make it even smaller, right?
Yeah, but it also shows how, the feedback, how is it important? Because with your experience with Grails was like, I don't know, like 99% just a web framework. I don't know if anyone else used Grails in a different shape or form. I mean,
Grails was just a web. People talk about Micronaut versus Grails, but Grails was just a web framework. I think a really good one for its time, and and probably Micronaut is still behind Grails in many areas. Like, it doesn't have like scaffolding or CRUD views or anything like that, which is really a cool thing that Grails featured. But Micronaut is much more broadly applicable to a lot more workloads. You can write message-driven microservices with Micronaut, or command line apps, or we have people using it with JavaFX apps. There's lots of potential use cases, because ultimately Micronaut is a programming model for any kind of app, anything that has static void main, right? It's a dependency injection engine and a particular way to do things that helps structure your app. And people can argue, the value or the of dependency injection, but or not. But ultimately, my opinion on that matter is like dependency injection has always encouraged developers to structure their apps to make them more extensible and modular, and that's the real benefit of dependency injection, because you can design an application that is easily extensible, easy to replace components, loosely coupled, and well structured. Whilst generally applications that don't feature dependency injection tend to be hardwired together, hard to extend, hard to customize, and with Micronaut, for example, Spring or these things, you can write like a bean created event listener and listen for when a component is created, or write event listeners that hook into the way they work, or replace components. And it's that extensibility and modularity that is the benefit of a dependency injection system.
Yes, and plus that Micronaut did not invent any new programming model. Like I remember that was my first impression when you announced Micronaut at GraalVM in 2018. I remember I watched the presentation after the conference, and when I've seen it for the first time, I was not very impressed in a way that this is just another Spring Boot kind of framework, because I didn't get what are the fundamentals of Micronaut. And at that time I was really into Ratpack. I loved the features of Ratpack, but the problem with Ratpack was that it introduced completely new programming model. Like, you had to implement those handlers, you had to think reactively from scratch, while I think you did a great job by just using the same mental model, like for people that were coming from Spring Boot experience. You just sit down in front of Micronaut project, and everything feels very familiar, even though the core is completely different if we compare to many other Java frameworks, right?
Yeah, that's right. I have been a Spring developer, and our goal with Micronaut was always to create like a more a better, more efficient version of Spring. If I'm being honest, like a more optimized version of Spring, because we spend a lot of time profiling Grails applications and Spring applications, and you get to the point where you hit a wall like this. This is all like the bottleneck here is reflection. It's your runtime creation of proxies and so forth. So we tried to create a more optimized, more efficient version that uses compilation time processing, but that retained the productivity. So like for us, it was like there's no point in reinventing the programming model wheel, because there's nothing wrong with the programming model. It's more how do we make the runtime more efficient, and that's what we've tried to do with Micronaut, and obviously make it. Then GraalVM came along, and then how do we make it like automatically native friendly for native executables, and that proved to be quite easy.
We talked about the design decisions that you would like to change. Let's look at Micronaut from the user perspective. When you use Micronaut, what is your favorite feature?
One of them is how the efficiency of Micronaut affects the developer experience. So Micronaut starts like lightning fast, right? It's really, really fast to start. So that has knock-on effects to how it feels to work with it. Because it starts instantaneously when you run an integration test, for example. Like with Grails and Spring, they had extensive mocking facilities that you had to learn, because starting up the whole app was time consuming. And so you had this separation between integration tests and unit tests, and integration tests were slow and you wrote few of them. Micronaut on the other hand starts so fast that you write a lot more integration tests, a lot more functional tests, and we have projects where you have thousands of functional tests, and they run instantaneously. And now with our recent test containers integration, which shares the test containers amongst all of the tests, we've solved the problem of the database, because the only bottleneck was then how do you start the test container quickly so the database is only started once. And that development experience of executing tests quickly has massive benefits, because you get the feedback loop really quickly. And Micronaut doesn't have extensive mocking libraries or facilities, because you don't need them generally, right? We do have one annotation to mock out a bean if you really want it. But in general, you don't have to, majority
and you don't have to even use a mock, in a mock terms, right? Because you can just add some dummy implementation of
exactly. So it's that kind of where the kind of efficiency of the startup and the environment has implications on the developer experience. And then the other area that I think is great is its compile time nature. So, the way we made the compiler extensible by end users or by the modules. So the compile time nature is great because we have great error reporting. So with a purely runtime framework, if you put a value into an annotation that is invalid or incorrect, it fails at runtime, right? It's like, this is, and you get an exception at runtime that is maybe difficult to understand or whatever, or it takes time to get to that exception. Whilst with Micronaut, a lot of things get caught during compilation. So if you put an invalid value into an annotation, the compiler will fail, and you get a Java-C compilation error, which is awesome, right? You get it right before your application is running. And it even extends to things like Micronaut data. If you write a Micronaut data repository and you define a finder that is on a field of an entity that doesn't exist, you get a compilation error. Exactly. Or if you define a return type that's not possible or is incompatible with the query you're trying to write, you get a compilation error. And that means the feedback loop is shorter because you're getting compiler errors, and you fix those before you get the running application.
And it's also great how Micronaut integrates with the existing tooling. I love IntelliJ, when I get code completion on Micronaut data repositories, it just suggests me what fields I can use and operators. Maybe this is not like a deal breaker, but it's from the productivity perspective, it's such a useful thing.
Yeah.
Combined with compilation errors, you made a typo. Everyone makes a typo.
Yeah.
Every once in a while, and then you just get a very fast feedback.
Yeah, and it even extends to like annotation values. If you put it's typical to in a web controller, try and bind a parameter to an annotation, and if you get those misaligned, you get a compilation error, or you put something invalid. So I think that's really cool, I think the final area that is really nice is the way we made the compiler extensible, like I mentioned. And I love, for example, the Open API module, where you add it, and basically it hooks into the compiler, and we've defined this whole model where you can, in a language neutral way, visit the AST of the project, which, speaking about ASTs is maybe for a lot of developers not something they want to know about, but it's nice that you can as a user, you can open the API module, add it to your project, and as you compile, it's generating your Open API definition. And because we can do things because Micronaut is source code processing based, we can do things like the Open API module, for example, will look at your Java doc and include it in the API definition for all the parameters and generate your Open API based on the Java doc comments that you, as a developer, normally write, which is really nice. Yeah, and I know that a lot of developers do the inverse. They generate their Java code from an API definition rather than the Open API, but we have that as well. But just that integration where you can look at the source code and see the Java doc comments and include them in as you compile Open API definitions is really cool. And I think that infrastructure can be extended to lots of different use cases, right?
So that's one feature. What would be the productivity boost that Micronaut gives you? What would be the second Micronaut feature? Let's say maybe what's your favorite part of the Micronaut framework as a library?
So I think that I've always been, in Grails, my favorite area to work on was GORM. And I've always liked the database use case. And Micronaut data is definitely a favorite of mine. I love, and I like the decisions we've made with Micronaut data, making it extensible, taking that experience of building GORM. In fact, we even reused parts of GORM, forking some of it and so forth. Adding the compilation time checking to Micronaut data, sorry. And now, we have implementations that, we have support for JPA, which, a lot of people are familiar with, but, within the implementations, I really like the JDBC implementations. It's really simple, right? It's just stateless. And if you like SQL, it's just I have this object, and it works with records. Yeah, Java 17 records. So you can say, I have this SQL query, just bind it to this record and, return it for me. And, stateless. There's no notion of the session or flushing or synchronization. It's just really lightweight, which is, great for so many use cases. And then more recently, obviously, we did the MongoDB support, and we're going to keep expanding Micronaut data because, data access is such a critical aspect to most people's applications, right?
So let's say I'm a newcomer to Micronaut framework. I have some experience with Spring Boot and other Java web frameworks. Where should I start learning Micronaut? What would you recommend me as a newcomer?
Way to start is through our guides. So if you go to guides.micronaut.io, we have an extensive set of guides that take you through getting started, Hello World, beginners kind of guides. But they also go beyond that, right, to specific use cases. Like if you're using a relational database, there's, guides on Micronaut data. for JPA, for JDBC, for, R2DBC if you're looking at reactive use cases. And, there's a lot of detail there. We have guides on integrating Kafka, messaging systems, and there's also guides on like beginners concepts, right? So recently, there is a guide being published on dependency injection and understanding it. So if you don't have a basis of that, or you want to understand the basics of dependency injection, there's good guides on that. And the guides are good because they have, they're small, focused. They're multi-language. So if you're coming from Java, then you have a guide in Java. There's also the same guide in Kotlin, the same guide in Groovy. So you can focus them on your language. And there's also, there are multi-build tools. So whether you're a Gradle fan or a Maven fan, you can choose one of them that suits like your model of development, right? Mm-hmm. And each guide also comes with a sample application. And the guide system that we put in place is really interesting because, it basically is another automated kind of build process that goes with each Micronaut release. So every time we do a Micronaut release, we bump the version of the guides, and it builds a whole new guide for the latest version of Micronaut with sample code in all the languages, right? Sample code in all the different languages, all the different build tools, and tested snippets so that we know they work. They're smaller, focused guides. If you're looking to go beyond that into more detail, the Micronaut user documentation at docs.micronaut.io has user doc reference documentation. And I think the last time I looked, the docs documentation for Micronaut Core is like 250 pages of user documentation. So we have put a lot of focus on documentation, guides, tutorials, to help users get started. And then of course, if you do want to create an app from scratch, you can go to start.micronaut.io, and we have an application generator that you can create your app in whichever language with whichever features that you want to use, and get started, import it into your favorite IDE.
Or even push to GitHub, right?
Or, it has a great feature. You can download a zip file, or you can push directly to GitHub, and it will
then clone the repository.
Clone it and start development.
That's brilliant.
So that's a great way to start creating your first app and getting it started with Micronaut.
I hope we will, do this similar conversation in the future, I guess. Maybe when Micronaut 4 is already released, we can sit down and discuss.
That would be awesome.
Thank you very much, and have a good day.
I would like to thank to all the Micronaut Foundation's sponsors who made this podcast possible and made possible not just the development but also the advocacy of the framework. And those are Object Computing, Microstream, Safri.net, Visor Games, Gradle Enterprise, and JetBrains. Many thanks to all of them. Also many thanks to all the community individuals who sponsor the foundation as well. Without your support, it will not be possible to maintain the framework. So thank you a lot, and I hope you enjoy the interview. Many thanks to Szymon Stepniak for providing us this material. Don't hesitate to check Szymon content in YouTube or Twitter or in the website. It's fantastic material. Without further ado, go and update your projects to Micro 3.7.0 and enjoy using the Micronaut framework. Thank you.